Hi, everyone, and thank you for joining my talk. Today, I'm going to be talking about customizing and evaluating LLMs. So I'm planning on saying this, but as you probably have heard, Google has launched Gemini. Their long-awaited model is supposed to beat GPT-4. And I noticed an interesting thing today, which is that when they published the results, the metrics that they used to evaluate their model were pretty different from the original metrics that OpenAI used to evaluate GPT-4, which means that we're kind of comparing apples to oranges. And so I thought it was funny that today I'm speaking about this topic when it seems like this is a prevalent problem, even in like the most advanced labs. So today we're going to be talking about customizing and evaluating LLMs, and hopefully this is useful to not only Google and OpenAI, but everyone here. So starting with a short story, just to make this more realistic. You get into your office on a Monday and you see an email from your boss. He spoke with the CEO of the company who promised the board of directors that the company will live up to the promises in its pitch deck to be AI driven. With everyone talking about this in the news, I'm sure you, our genius ML engineer, can figure it out. Everyone is doing it, so why can't we? So you sit down to think about what you should do next. Everyone is talking about chat for this, chat for that, so I guess we should chat with our product. But how can you get some LLM that was trained on God knows what to answer questions about your product? How can it answer correctly, know its limitations, and how can you make sure it's performing well enough before you put it in front of your users? Let's go ahead and find out. So James already presented me. I won't repeat everything that he said, but my background is a combo of physics, machine learning, and computer science. And I'm really passionate about building tools that help machine learning teams work together. And I'm also a strong believer in open source and the role it has in the world of ML. Those two things led me to found the company that I'm working at, which is called DAGS Hub. And we're basically building a platform for ML and AI teams. And I also do the MLOps podcast. And hopefully this, at least to a certain extent, answers your question of why you should listen to me. And before I move on, I'll just say, I can see that there are messages in the chat and stuff like that. I'll answer all the questions in the end, but feel free to write them as you have them in mind, and I'll go over them from top to bottom. So what are we going to cover today? If you're not living in a cave, you probably know that LLMs have been making a lot of buzz. And this buzz doesn't seem to be dying down. And as LLMs become ubiquitous, everyone is scrambling to apply them in their company and inside their products. And this is specifically seems that due to the fact that one of the best things about ChatGPT, the LLM that slingshotted all others into the general public sphere, was its chat UX. Everyone is in the mental model of chat for my product. But it doesn't have to be the case. Two major challenges have arisen, or more precisely, reappeared in this context yet again. The first is customizing, and the second is evaluating your models. And what I'd like to do today is cover the basics and provide some ideas on how you might go ahead and customize your LLM to your needs, followed by how to evaluate them and make sure that they are performing well and within the constraints that you need them to. So a quick LLM recap with a few thoughts. When we say LLMs or large language models, we're not just talking about fancy chatbots. They're sophisticated systems that understand and generate human-like text. And the essence of LLMs lies in their capacity to not only parse language, but to understand its nuances and generate contextually relevant human-like responses. They're not just algorithms that simulate conversations, and they're not even just participants in a conversation. What I'd like to argue today is that thinking about them in this way is sort of the banal or boring approach. The boring use case is chatting with your application. But if you think about LLMs as automated reasoning engines, you can come up with infinitely diverse applications. It's not just a bot chatting with a human, it's a bot that can do things. And though, of course, this isn't a fully solved problem just yet with agents and everything, I've already seen and heard of real-world applications that take advantage of this mental model. So to give an example that I found eye-opening, in a fraud detection use case, and this is a real use case that's been applied in production, a team decided to use an LLM to play the role of a gullible person that is just asking to be defrauded. When scammers would reach out, the bot would interact with them, and in the process of being scammed, would get some identification detail from the scammer. This was then sent back to a database and used to check against for future transactions, effectively blocking those accounts from the relevant platform. So this is probably not what most common LLM applications look like today, but I think as time goes by, they'll look more and more like these things. So why do we want to customize LLMs? LLMs were trained on the entire internet, but sometimes they need to work for data they weren't trained on, whether it's a specific domain knowledge or, more importantly, organizational knowledge databases. So take, for example, a legal firm that is using an LLM for document review. A general model might grasp the legal jargon, the basic one, but a fine-tuned model with specific legal data sets can understand the nuances of case law, statutory language, and of course, the specific cases that this firm is working on, leading to improved accuracy and utility. Similarly, in healthcare, a customized LLM trained in medical literature and patient data can interact with clinicians more effectively, understanding complex medical terminology that a generic model might misinterpret. So in the context of a medical LLM, customization is not just beneficial, it's imperative. By tailoring an LLM, we gain control over its behavior, ensuring that it operates within the strict boundaries of medical accuracy. It must not only understand complex medical terms, but also provide valid references and avoid any potentially harmful misinformation. In a domain where the stakes are high and the margin for error is low, the precision of a customized LLM can make all the difference in patient outcomes and trust in AI-assisted healthcare. Last but not least, proprietary data is arguably the new moat. The more you have it, the better your product will be, and the better your ability to collect more data and improve your model even more. Note that since incumbents typically have more users and data, this might help them maintain control or tighten control over a market, but can also be used by smaller startups if the incumbent isn't as data literate as you are. Beyond enhancing user experience and ensuring accuracy, customizing LLM applications also serves as a strategic move in a competitive market. And a tailored LLM can differentiate your product by providing a unique experience or specialized knowledge that generic models can't offer. So, assuming you agree with me so far that we probably want to customize LLMs, let's go ahead and start. But unfortunately, customizing LLMs is still pretty hard. Finding enough high-quality, domain-specific data for training or fine-tuning an LLM can be a pretty significant obstacle, and this data must be representative, diverse, and free of biases to be effective. Incorporating specialized knowledge into an LLM often requires expertise not only in machine learning, but also in the relevant domain, whether it's legal, medical, financial, or some other field. And that means that the technical people who are doing this customization need to communicate and work well with the domain experts who are usually less technical. And we shouldn't overlook the ethical dimension. LLMs can perpetuate and amplify biases that are present in their training data, and ensuring that the models are fair and unbiased is a complicated challenge in general, and can require sort of careful data curation and testing. And obviously, it's even more challenging when you get to LLMs due to the volatility and complexity of those models. And last but not least, customizing LLMs, especially through methods like fine-tuning or retraining, can require a lot of computational power, which could be costly and time-consuming. And even once you customize the first version, they're going to need ongoing updates and maintenance to stay current with the latest knowledge and data, which can be a resource-intensive process. So let's dive into the meat of it. How can we approach customizing our LLMs? When it comes to customizing them, there's a spectrum of strategies that is at our disposal. And here's how I personally rank the different ways to customize an LLM by the level of difficulty and the effort required. I'm going to go over them in a moment to provide tips, but at a bird's eye view, we have the easy modification zone, which I put into that category prompt engineering and custom logic. They're like a quick toolkit for instant customization, which require no training, but a sort of creative approach to guiding the model. If you're not sure what to do, start experimenting with them. These are things that you could sort of hack together, and they might even be within reach for non-technical folks within your team. In the middle, we have the hard mode, which could be relevant in cases where you have more resources to apply and the easy mode is not good enough for you. They'll usually require a dedicated team member or an entire team and a lot of technical know-how. So this is also not a linear scale, even though it might look this way. And the distance between tier 3 and 4 can be huge. Finally, in the danger zone, I really wasn't even sure if I should include this here, since these are sort of developments you could consider research or building a model in and of itself. I think that there are very few organizations that can pull these off. They're resource-intensive processes, and you're basically creating a new model from scratch. They're not typically recommended unless you're tackling some exceptionally challenging problem that existing models can't solve, or you're operating at the forefront of AI research, like at OpenAI, or Google, or whatever. And I'm probably not going to go into them anymore during this talk, unless there are specific questions. Hopefully I'll be able to answer. So the first two tiers are prompt engineering and custom logic. So prompt engineering, or few-shot learning by way of prompt engineering, are good for providing context and nudging the model towards the desired output. It suffers from the problem that prompt engineering still today is an arcane technique. You need to know the magic spells, and there's a lot of non-trivial quirks to how to do it well. But we've seen personally at DAGs, and when we've applied this in a smart way, that it gets to really awesome results without requiring to bring in data scientists or ML engineers. Custom logic means defining some external logic, and by external, I mean external to the model, that processes the LLM's inputs and outputs. And this is suitable when you want to enhance functionality without changing the model itself. This can include retrieval mechanisms for getting external context for your LLM. We'll talk about that in a moment. One major benefit of these methods is that in principle, they don't require data to work, more or less, right? Perhaps you need a few examples or something like that. So the overhead is basically none. Now, also, implementing custom logic around the model is possibly simultaneously the most popular and most overlooked customization. It's the most popular because of RAG, but overlooked because it doesn't have to be just RAG. Why mess with the model if you can solve your needs by working around it? You can set up, again, this is all examples that I've heard, I've seen or heard applied in the market, or we've applied them ourselves. So you set up rules to filter responses, use more classical, controllable, explainable models to verify the input and the output, and modify the model's context depending on their results, or use APIs to get reliable context, which reminds me that we finally need to talk about RAG for a few moments. So RAG, or retrieval augmented generation, this sort of falls under the custom logic category, since we're not directly affecting the model, but creating an efficient context retrieval mechanism for it. This is also probably the most popular way to customize LLMs, again, maybe aside from prompt engineering. And here, the model dynamically pulls in information from external databases to inform its responses. And this is usually based on some vector similarity search, a topic for a different talk. I'm sure there are a lot of talks this year about this. And the main advantage of RAG is that updating the model context is much simpler. You simply update the documents it retrieves from compared to updating the model itself. Now, note that this introduces another dependency which needs to be managed, can slow the application down, and is another point of failure that might be hard to debug if your LLM isn't providing the desired responses. But I'll also say that now when everyone is talking about RAG, I think most people think about vector databases, and notice that the name doesn't really mention that. And it doesn't have to be based on vector search. You might use the model to define a different query and use that to supply context. Or use information that you know about the customer or the user to provide that context. That would still fall under this category. And I think that's going to be as common, if not more common, than the vector similarity search, which requires, again, a lot more arcane understanding of how these things work to make it work properly. So In the second tier, in hard mode, we have PEFT and LoRa, or parameter efficient fine-tuning plus low rank adaptation. And these are methods for efficient domain adaptation. This shouldn't suffer as much as 4 from catastrophic forgetting. And it's useful when you need more than a nudge from prompt engineering, but want to avoid the full cost of retraining. I really recommend you read the papers behind this, since I believe this is going to become more and more of an important tool in your customization toolbox as time goes by. And by the way, some of you might have heard of LoRa only in the context of diffusion models, but it works equally well for LLMs that do text generation. Fine-tuning and model retraining involve comprehensive fine-tuning and retraining of the model on new data. It's a deeper level of customization for when your use case demands a model that the pre-trained version simply can't provide. However, the technical requirements for this are very high, and I'd argue that the 2 steps that have the largest gap here are between PEFT and LoRa and fine-tuning and model retraining. Again, if I don't include the hard zone. I think most industry teams that are pursuing this method have low chances of success. So I wouldn't go here unless you've exhausted all the previous methods and are certain that you won't achieve your needs from them. As a side note, just to give you some like ballpark figures from this, when OpenAI launched the updated APIs and did their recent dev day, they opened a registration form to get GPT-4 trained on your data, which you could argue is similar to 4 plus 5. And they estimated the cost of this at $2 to $3 million. So this gives you some estimate for whether or not your organization can afford doing something like this. And as we ascend, RLHF, or reinforcement learning from human feedback, is a way to imbue models with nuanced understanding through interactive feedback from humans. This approach is most beneficial when the model's output must be highly aligned with complex human judgment. And to be honest, when I was ranking these things, I wasn't sure if I should put 4 before 5 or the other way around. So I think these are hard things to set up. And if you look to, for example, Andrei Karpathy's talk, which I'm linking to in the end, about GPTs, he ranks RLHF higher. And that's why I decided to go with this ranking. So just to double down on LoRa, I think that LoRa and PEFT are really, really important methods that are often overlooked for domain adaptation. And I recommend checking them out. And if the previous methods have not gotten you where you need, or if you need a more flexible solution, so taking a model that you know works and moving it into a domain that is, I don't know, different, like fundamentally different from the origin domain that the model was trained on, you should use these methods in that case. And this has also the advantage of being reasonable to do for each customer. So if you're trying to build something where you say, I need to redo it or do a domain adaptation per customer, LoRa might be the way to go here. So of course, it doesn't have to be just one or another approach. You can use multiple things together. So if you're using 1, 2, and 3, they can work great with each other, and specifically RAG works with every other customization technique that I've seen. And now that we have our customized model, right, or the approach is to customize our model, we need to evaluate it to make sure it's behaving nicely. But of course, evaluating LLMs presents its own set of complex challenges. First, we need metrics that truly capture the model's performance in all necessary dimensions, not just the accuracy, but also fluency, coherence, relevance, consistency, and user satisfaction, and comparative metrics like the ELO rating. And I think that the Google Gemini issue that we've seen today is sort of an example of that. So you want to make sure that you're comparing apples to apples. If it's a publicity issue, then maybe it doesn't matter as much. But when you're trying to prove to yourself that your model is actually good enough to go to production, you want to make sure that you're evaluating it for real with something that actually conveys the value or the change compared to previous versions. We also need to make sure that our evaluation data is representative, free from biases, covers relevant edge cases, and the things we actually care about. This might be more than one data set. And we want to make sure that we understanding how and why our model made the decisions it did is always difficult, but with LLMs, it's nearly impossible. And this becomes a critical point in high-stake domains like medical and legal applications, where user trust and compliance with regulations are paramount considerations. And last but not least, these are sort of some of the main challenges in LLM evaluation. And many people smarter than I have claimed that this is currently the biggest gap in the LLM world. And I tend to agree. One additional point here is that evaluation tends to be case-by-case specific. So it's really hard to just copy-paste things that other people have done. And a lot of judgment and customization is needed here too. So let's go over a few ideas that I think could be useful when you're building your evaluation capabilities for the LLMs that you're customizing. Our evaluation toolkit needs to include mainly two types of evaluation tests. The first is automated, and the second is arguably semi-automated. You could call this reference and preference-based methods, which I like. I like this terminology. So reference-based methods are things like Rouge, which is a metric that's predefined. You can basically calculate it for your model and create sort of a quantitative benchmark. And preference-based methods leverage human choice for comparative evaluation. So, for example, you take two options that were generated as a response to the same prompts by two different models or two different model versions, and asking people to decide which one is the better option. And then we can use that for evaluation, for example, to calculate the LO rating. I actually have a project on DAG's Hub called DPT that has an evaluation example for doing exactly that. So that could be one way to imbue human judgment into the evaluation process. The second thing is you need to build specialized data sets. Think of them kind of like data unit tests focused on crucial areas like toxicity, biases, and edge cases. So these are the yardsticks that we're going to use to ensure that our models behave responsibly. And we can take a sort of pass-fail approach to some of these even. Deciding that if a model fails, for example, a toxicity test, they cannot be deployed to production. And this is really, it's relatively straightforward. And I think it's really powerful to incorporate these. And I haven't seen this done enough. And I think we're going to see, again, more and more of this happening within the industry. The other thing that you can do is you can utilize a stronger LLM like GPT-4 for meta evaluation. So in that case, we're posing complicated questions about, for example, consistency with the source material or the potential for bias in the outputs, pushing the boundaries of traditional evaluation methods. So this does require defining the evaluation properly, but examples I've seen that could prove useful are asking the stronger LLM, is this generation consistent with the source material? Or does this result contain information that might be interpreted as toxic or biased? And this works surprisingly well. I'll also share a tool in the end that helps you do this. The other thing that you can do is output validation and collecting feedback from production. You can release your product to early users who can validate the outputs and give feedback. And that can be a great way to get more data on where to improve your model, where missing guardrails might be, and even data can be used to improve it or create a data set of failure modes that need to be tested against. Note that user feedback is sparse, but you can do smart things like measure when a user asks the model to answer a second time, or measure other product interactions that you anticipate are related to your LLM performance and use that as well. Now, obviously, this is very case by case, but this could be really valuable. Finally, despite all of these things, there's no replacement for also eyeballing your model outputs. Many times metrics might not have the full picture, so manual examination is recommended, but don't only do that. So tooling, I'm going to go over this quickly and then try to answer a few questions. So a few tools that I think could be useful for the process of customizing and evaluating LLMs. MLflow is a great tool for evaluating and customizing LLMs. It offers great features for prompt engineering, experiment tracking, which you can use to track fine-tuning, LoRa or retraining experiments. And it even has features for tracking evaluations of LLMs. Hugging Face has the Evaluate and the PEF libraries. They're open source libraries that provide a ton of metrics out of the box and scaffolding to help you run PEF or LoRa easily. They both integrate with MLflow and can be used to easily calculate the reference-based metrics that we discussed earlier. For the actual LLM model testing, the automated kind, Giscard and DeepChecks are great solutions. Giscard is an open source library that integrates with MLflow and provides interactive reports as well as metrics that utilize LLM explainers, standard metrics, and more, and will help you get started quickly. And DeepChecks is a hosted platform that does that. For human eval methods, Label Studio is a tool that supports comparison and ranking templates for text, which means it can be used for the various preference human-in-the-loop eval processes. And then DagsHub, we help you integrate all of these things and provide a hosted environment to use both MLflow and Label Studio, so you can use that to manage and evaluate your LLM projects easily. To wrap up, we navigated through all of the complexity of customizing and evaluating LLMs, understanding the challenges and the strategic workflows to overcome these things. And in terms of tools and resources, I hope I provided some things that you can use. This is sort of recommended further reading if you're interested. And I'll just show this thing because it's nice and go back to this in case anyone wants to take screenshots. Let's take a few moments to answer questions. So I see there's one question from Anthony. Does doing LoRa help with RAG type applications? Is there a specific way of training LoRa's for those type of applications? So I think that RAG is sort of, and LoRa are kind of like orthogonal. You can do both. I'd use RAG when you're specifically trying to get the model to answer about in a certain context. And LoRa when you're trying to get it to sort of change the way it thinks to a different domain. So if you give it some context and you ask it questions about that, that's one thing that you could do. But when you LoRa the model, it's going to sort of come at the problem that you're asking with a sort of domain expertise that's closer to the domain in which you want to operate. And so I think you should first do RAG because it's simpler. But if that's not enough and the model kind of has a tendency to maybe misinterpret the documents that it's getting or something like that, then using the LoRa approach can improve the performance. Now on the Q&A side, I see David is asking, in the field of evaluation, I would also add how to assess the right LLM for a given use case. Do you have any advice, tips, or tools for this? Sorry, Alex, you wanted to say something?
No, I'm just saying we're coming up on time here. So being quick, a few seconds on that one. Otherwise, we can move to Discord and wrap it up.
Sure. So just to answer this, there are a lot of tools that help you create a test suite of prompts you want to use, and then create a table. MLflow does this as well, where you run your prompt across multiple models, and then you can eyeball the difference. And you can also use this result to calculate some metrics depending on whether or not you have the preference option set up or you have some reference methods. So that's how I would approach this. But you're right. Like you might have different LLMs that are better for different use cases, and you might even want to deploy multiple LLMs for different use cases depending on the questions that you need to answer. So that's, I think, what we have time for.